Have you ever wondered how we make phone calls or watch live TV from across the world? These everyday activities are made possible by a fascinating piece of technology orbiting high above us. The answer lies high above us with geostationary satellites. These satellites play a crucial role in our modern communication systems. These special satellites orbit Earth at a very specific height, about 22,236 miles above the equator. This precise altitude allows them to maintain a constant position relative to the Earth's surface. What makes them unique is that they travel at the same speed as Earth's rotation. This synchronous movement ensures that they are always in the same spot in the sky when viewed from the ground. This means they stay parked over the same spot on Earth all the time. This fixed position is incredibly useful for consistent communication links. Imagine a string connecting you to a ball above your head. The ball represents the satellite and you are the Earth. If you spin around, the ball stays above you, right? This is similar to how a geostationary satellite remains in a fixed position relative to the Earth. That's similar to how a geostationary satellite works. It stays in the same spot, providing a stable platform for communication. Because of this fixed position, geostationary satellites are like communication superhighways in space. They relay signals efficiently and reliably. They help us stay connected by relaying signals for television, internet, and phone calls across vast distances. Without them, our global communication network would be far less efficient. They also have a great view of Earth, helping us with weather forecasting, disaster management, and even spying. Their ability to monitor large areas of the planet makes them invaluable for various applications. For instance, meteorologists rely on geostationary satellites to track weather patterns and predict storms. This information is crucial for preparing and protecting communities. In times of natural disasters, these satellites provide real-time data that aids in disaster relief efforts. They help coordinate rescue operations and deliver aid to affected areas. Additionally, geostationary satellites are used for surveillance and security purposes. They can capture detailed images of the Earth's surface, which are used for various strategic and defense-related activities. Overall, geostationary satellites are an integral part of our global infrastructure. They ensure that we remain connected, informed, and safe no matter where we are on the planet. Before a geostationary satellite can soar into space, it needs to be built. This process involves a series of meticulous steps, each requiring precision and expertise, and it's no easy feat. The journey from concept to launch pad is long and complex. Building a satellite is like assembling a giant high-tech puzzle, with each piece playing a crucial role. Every component must fit perfectly to ensure the satellite functions as intended. First, engineers design the satellite's brain, the command and data handling system, which controls everything the satellite does. This system is crucial for the satellite's operations, as it manages data and executes commands. Then, they add communication systems, like antennas and transponders, which allow the satellite to send and receive information. These systems are vital for maintaining contact with Earth and transmitting data back and forth. But that's not all. Since space is a harsh environment, the satellite needs a strong outer structure to protect it from extreme temperatures, space debris, and radiation. This protective layer ensures the satellite can withstand the rigors of space. Finally, once all the pieces are in place, the satellite undergoes rigorous testing to ensure it can survive the journey and function flawlessly in space. These tests simulate the conditions of space, including thermal extremes and vibrations, to guarantee the satellite's reliability and performance. With the satellite built and tested, it's time to prepare for launch. This is a critical phase where every detail is meticulously checked to ensure the satellite's functionality in space. Engineers and scientists work tirelessly, running final diagnostics and making sure all systems are go. The satellite, a marvel of modern engineering, is now ready to embark on its journey. The satellite is carefully transported to the launch site, often near the equator, to take advantage of the Earth's rotational speed. This location helps the rocket gain extra velocity, making the launch more efficient. The satellite is securely packed in a protective casing to shield it from any potential damage during transit. Upon arrival, the satellite is delicately attached to a powerful rocket. This process, known as integration, involves precise alignment and secure fastening to ensure the satellite remains stable during the intense forces of launch. This rocket acts as the satellite's ride into space. It's a towering structure, designed to withstand the immense pressures and temperatures of launch. The rocket and satellite together form a sophisticated system, ready to breach the Earth's atmosphere. Meanwhile, engineers fuel the rocket with special propellants that will give it the massive thrust needed to escape Earth's gravity. This fueling process is highly controlled and monitored as the propellants are extremely volatile and require careful handling. Before launch, the weather is carefully monitored, as clear skies are crucial for a safe liftoff. Meteorologists provide constant updates, ensuring that conditions are optimal for the rocket to soar into space without any atmospheric disturbances. The launch team, a group of highly skilled engineers and scientists, meticulously checks and rechecks every system on both the rocket and satellite, ensuring everything is in perfect working order. This rigorous process involves multiple simulations and tests to preempt any possible issues. With the countdown clock ticking, excitement and anticipation fill the air as the launch day arrives. The culmination of years of hard work and dedication is about to be realized. Everyone at the launch site is on high alert, ready to witness the satellite's journey into the vast expanse of space. The moment has arrived. With a deafening roar and a burst of fire, the rocket carrying the geostationary satellite blasts off from the launch pad. The powerful engines push the rocket skyward, overcoming Earth's gravitational pull. As the rocket ascends, it sheds stages like discarding used-up parts. This makes the rocket lighter and more efficient as it travels further from Earth. The journey through Earth's atmosphere is turbulent, but the satellite is safely tucked inside a protective fairing, shielding it from heat and pressure. Finally, after several minutes of intense ascent, the rocket reaches a predetermined altitude, and the fairing separates, revealing the precious cargo within, the geostationary satellite ready for its next adventure. Reaching for the star's journey to geostationary orbit. Ejected from the rocket, the satellite begins its solo journey to geostationary orbit. It's not a direct trip, though. The satellite embarks on a carefully calculated multi-step process. First, it reaches a temporary elliptical orbit called a transfer orbit. Imagine an oval shape around Earth. That's the path the satellite takes. Then, using onboard thrusters, the satellite gradually adjusts its speed and altitude. This process can take several days and requires precise maneuvers to ensure the satellite reaches the exact location and speed needed for geostationary orbit. It's like a delicate dance in space, with each movement bringing the satellite closer to its final destination. Once the geostationary satellite reaches its designated position, it's time to unpack. Remember those solar panels and antennas we talked about earlier? They were folded up neatly during launch to fit inside the rocket. Now, like a butterfly emerging from its cocoon, the satellite deploys its solar panels to capture energy from the sun. These panels act like the satellite's wings, providing the power it needs to operate. The satellite also extends its communication antennas, which look like long arms reaching out into the void. These antennas are crucial for sending and receiving signals back on Earth. With all its components deployed, the satellite transforms into its final operational configuration, ready to fulfill its mission. Just like testing a new phone before using it, engineers on Earth run a series of tests on the newly deployed geostationary satellite. They check the satellite's systems, making sure everything is functioning correctly after its long journey and complex deployment. They command the satellite to fire its thrusters, ensuring it can adjust its position and maintain a stable orbit. They test the communication systems, sending signals back and forth to confirm the satellite can clearly hear and talk to Earth. Once all tests are successful, the satellite is declared operational. It's ready to begin its job, providing us with valuable services from its unique vantage point high above Earth. Now comes the exciting part. The geostationary satellite is hard at work. From its high perch in space, it acts as a watchful guardian, constantly observing Earth and relaying vital information. For communication, it acts like a giant relay station in the sky. Imagine it bouncing signals between different parts of the world, enabling us to make international calls, browse the internet, and watch live broadcasts. The satellite also plays a crucial role in weather forecasting, capturing images of cloud formations, storms, and other weather patterns. These images help meteorologists predict weather conditions more accurately, keeping us safe and informed. Some geostationary satellites even help with navigation, like a giant GPS system in space. As technology advances, so too will the capabilities of geostationary satellites. Imagine even faster internet speeds, more precise weather predictions, and even more advanced observation capabilities, all thanks to these powerful tools in space. Scientists and engineers are constantly working on new technologies and designs to make geostationary satellites even more efficient, durable, and capable. These advancements will further enhance our communication networks, improve disaster response efforts, and deepen our understanding of planet Earth. So the next time you make a phone call, watch TV, or check the weather forecast, remember the incredible journey of geostationary satellites and the vital role they play in our modern world. They truly are the silent guardians, connecting us all from their unique position.